All right, today we are working on section 3.3. We are going to talk about function notation. We are going to evaluate, interpret, solve, and graph functions using this new notation. But for now, we'll use our old notation for this warm-up where we have y equals 1/2 x minus 2. And we are given a domain of -4, 0, 2. If I want to graph this function using this domain, what do I need to find? What am I finding? The range. We need to know the range or the y values if we want to plot these. The domain gives us what? The x values. So we already know that we're going to have points that start with -4, 0, and 2. But we don't know the y values that go with them. In order to find those y values or find the range, what am I going to do with my x's? I have my x's, I need to find my y's. What am I going to do? Plug them in. So if I want to know the y value that goes with -4, I'm going to plug in -4 for x. So y equals 1/2 times -4 minus 2. When I plug in -4, what is half of -4? -2. What is -2 minus 2? -4. So that is one of my points. Let's go ahead and find all of them before we worry about graphing them. The next one, what am I plugging in for x this time? 0. What is half of 0? Nothing, or 0. And 0 minus 2 is -2. We've got one more we need to find. I'm going to take away our title and put it up at the top. For my last one, what am I plugging in for x? 2. So we've got 1/2 times 2 minus 2. Half of 2 is 1. And 1 minus 2 is -1. So -1 is the y value that goes with 2. Questions about what we've done so far? If you have domain values, you find the range values by plugging them in. Next, we need to graph these points. How am I going to get to the point -4, -4? Good. We go x, y. So my x-axis goes left to right. My y-axis goes up and down. So if we're going to -4 on the x-axis, we're going left 4. And then -4 for the y means we have to go down 4. And we would put a point there. What about the point 0, -2? Where are we going? Down how many? Down 2. So 0, -2 means I don't move left or right. That's where the 0 comes in. But -2 for my y means I'm going down 2 on my y-axis. Last, we've got the point 2, -1. Which way 2? Right 2 and then down 1. So we go right on our x-axis to +2 and then down 1 for that -1. Am I going to connect these points? No, why not? It's discrete. They gave me specific values for my domain. They only gave me certain numbers that I was allowed to plug in. I can't plug in any number in between them, just those certain numbers. Questions about the warm-up? I'm thinking we need to do some more graphing review. Only a couple people were responding about the graph. Other questions before we continue? Okay? All right, our big idea today is function notation. So in general, function notation will look like f of x. That's how we say this. F parentheses x means f of x. I'll make a note of that off to the side here. Or another way of saying it is a function of x okay, and it's equal to mx plus b, which again, we talked about that being our generic equation for linear functions. We'll talk more about what the m and the b mean later on. So f of x, or f parentheses x, is just another name for y. It doesn't change how you treat it or anything like that. It's just a different way of writing it. F is the name of the function, and x is in the domain of the function. So any number that you see in place of the x is part of the domain. So f of x represents the output of f corresponding to the input of x. Other letters like G and H are also frequently used to name functions, which means that you could see things written like G parentheses x or H parentheses x. It's important to note here that the parentheses do not mean multiply. This is a different use of parentheses. These parentheses do not mean that we multiply. All right, example 1 asks us to evaluate f of x equals negative 4x plus 2 when x equals 2 and x equals negative 2. Now, just for the sake of showing you a comparison, this is the same kind of problem as if I were to say y equals negative 4x plus 7. And x equals 2 and x equals negative 2. It's the same thing. So what would you do to evaluate it? Hunter?
You do it twice.
We are going to have to do it 2 times. But what do we do to figure out the answer to the problem?
You look inside the problem and practice around it.
Okay, you're on the right track. We plug it in. Just real basically, we plug in the numbers they give us for x. This is the same type of problem that we've done before. It just looks different. Okay, so first, what do they want us to plug in for x? A 2. So instead of saying f of x, because that's the generic way of saying it, I'm going to say we're evaluating the function at 2. So this is how I say what I'm plugging in for x. I'm going to plug in 2. But if I plugged in a 2 over there, I better plug it in for x on the other side. Now this is where some students get a little confused. This f parentheses 2, that's not changing the rest of the time. Just like y never changed when we plugged in numbers and we had y equals, y equals, y equals like we did in the warm-ups. This is going to stay f parentheses 2. Those parentheses don't mean to multiply. However, these parentheses do. So over here, I do need to take negative 4 times 2, which gives me negative 8. And then we'll add 7 to that. So negative 8 plus 7 is negative 1. So these parentheses on the left by the F, or whatever letter they have there, G, H, those ones stay put. That's where we say what we're plugging in. The other side we treat just like we would have done in the warm-ups when you plug in a number for x and you find the y or the output or the range. Do we have questions about that first part? Looks different, but the process is really the same. For the second half of the problem, what do they want us to plug in for x? Negative 2. So this time I'm evaluating my function at negative 2. So I'm plugging in a negative 2 for x. Again, on the left side by the f, it's going to stay f parentheses negative 2 the whole way down. But I can simplify the right side. Negative 4 times negative 2 is positive 8. 8 plus 7 is 15. So then we found both of the answers that they wanted. The function evaluated at 2 and the function evaluated at negative 2. So you're going to just focus on letter A. I'll bring B back in a minute. You're going to evaluate f at what numbers?
4.
Negative 4, 0, and 3. So I'm just leaving space to be able to do those. You're finding the function evaluated at negative 4, the function evaluated at 0, and the function evaluated at 3. On 2a for negative 4, when we plugged that in, oop, wrong pen. What did we get when we took 2 times negative 4?
Negative 8 minus 5.
And negative 8 minus 5 is? Negative 13. Next up, what are we plugging in? 0. So we replace our x with a 0. We have to take 2 times 0, which is 0 minus 5 gives me negative 5. Last up, we have to plug in
3.
So 2 times 3 gives me 6. 6 minus 5 is? 1. This time, when we plug in a negative 4, we have to be careful because what symbol is in front of our x? A negative. So we have a negative 4 minus 1. What's a negative going to be? A positive.
Wouldn't it be, but it would be minus 1.
Yep, we're still subtracting 1. That's correct.
So then I got a negative minus 1. Okay.
The opposite of a negative or a negative turns it positive, and then we worry about the subtraction. So what do we get for g of negative 4? 3. You are correct. So a negative 0 is really just 0. What is 0 minus 1?
-1.
A -1.
Well, why can't the entire problem be 0?
Because we're not multiplying by 0. Last up, we have to plug in a 3. -3 minus 1 gives me what?
-4.
-4.
So you're not doing anything with the G parentheses 3?
That's what I said this whole time. We don't do anything with this side, just like we never did anything with the y.
Okay.
All right, f of t, or the function of t, is going to be the outside temperature in degrees Fahrenheit, t hours after 6 a.m. Explain the meaning of each statement. So f of t represents the temperature. This represents temperature. And t represents our time in hours. I'll write it right next to it. T is hours. So on letter A, what number did they plug in for t? On letter A, they put in a 0 for t. So if 0 hours has passed since 6 a.m., what time is it?
6 a.m.
It's at 6 a.m. So at 6 a.m., what are they saying the temperature is? 58 degrees. At 6 a.m., the temperature is 58 degrees Fahrenheit.
How do you know that?
Because they said f of t represents temperature. So if f of some number is equal to 58, that's my temperature. T is hours. They plugged in a 0 for t, so 0 hours after 6 a.m. Okay, on letter B, what time are we working with? Okay, they plugged in a 6 for t. So 6 hours after 6 a.m. What time would that be? 12 noon. So at noon, or you could say 12 p.m., they're saying the temperature is what? Now, this might not make a lot of sense to say it in real life, but what did they put equals our temperature? Not a 1. N. They put an N. It's N degrees Fahrenheit. They didn't actually tell us what the temperature is. But that doesn't matter. We're just explaining what each statement means. Okay, on letter C, what time are we working with? First, what's our first time that we're working with? 3 hours. What time is it 3 hours after 6 a.m.? Okay. So the temperature at 9 a.m. What symbol did they put in the middle there? Somebody say it a little louder. Is less than the temperature at what time? What time? At 3 p.m. Because 3 p.m. would be 9 hours after 6 a.m. So they didn't tell us what the temperatures were, but they told us how we could compare them. So if you are asked to interpret or explain the meaning of a statement, you have to understand what they're using. So f of t, the function of t, was the temperature, and t represented our time, or hours in this case, after 6 a.m. Questions about interpreting? Okay, we'll move on. On these, we are solving for the independent variable. Which variable is our independent variable in general, x or y?
Y. X.
X. X is our independent variable. So on these problems, we are going to be solving for x. Notice that they didn't tell us that x is equal to -7. They said h of x is equal to -7. So I'm not replacing the x, I'm replacing the name of the function. So I'm going to be replacing this h of x with what? -7. That's what they told me it equals. The rest of it stays the same. The goal of these is to solve for x. Do we have questions about how we set it up?
Why do you need the H?
That's the name of the function.
Why can't you use
X
X?
is the variable. We can't have the function named x and the variable named x.
So
Why not the-
What?
Why not?
Did you get confusing? You don't know what you're talking about, the function or the variable?
Wait, so go to a different problem if it was X, like just parentheses in X equals without the H?
If it were to be like that, then we would say that that's an equation in one variable, not two. This one, technically, the h of x is in place of having something like a y. But if you just had an x there without a function name, then it is a different type of problem completely. Lydia, do you have a question?
No.
Okay. What do we need to do to get x alone here? This is a throwback to something we've covered already.
5.
Good. Add the 5. -7 plus 5 gives me
-2.
-2. So I have -2 equals 2/3 x. How do I get rid of a fraction attached to my variable?
Multiply by 3.
Reciprocal.
Multiply by the reciprocal. What's my reciprocal?
3/2.
3/2.
That's gonna take first place.
Yes.
Are we ready to continue?
Yeah, we've been ready.
My fractions cancel each other out. What is 3 times -2?
-6.
And then divide that by 2. So this gives me -6/2 equals x, but -6/2 is what? -3. So that's what they wanted us to do. If we're solving for the independent variable, we are solving for x.
So it can stay on that side.
Sure. If you want to rewrite it as x equals -3, that's fine, but it doesn't need to be rewritten that way. On letter B, f of x equals 6x plus 9. Find the value of x for which f of x equals 21. What's the first thing I'm going to write now? 21.
Equals 6x plus 9.
Good. Equals 6x plus 9. They told me to replace f of x with 21.
Okay.
So wouldn't you have to put the 21 in the 6x?
We're not plugging 21 in for x. 21 is f of x.
Gotcha.
So we replace the f part with the 21. Subtract the 9 on both sides. We get 12 equals 6x. What do we get for x?
2.
X equals 2, or 2 equals x. It doesn't matter to me which way you write it. So if we are graphing from function notation, we make an input-output table to find our ordered pairs. We've done that before, input-output tables. We graph the ordered pairs. We've also done that. And then our third step is to draw a line through the points, which we have done when we've had continuous functions or continuous domains. And on these, if a domain is not specified, then we assume it to be continuous. It's important to know that when you make your input-output table, you might have to pick what you plug in for x. It might not be given to you. You might have to pick your x's. What do you think is easy to plug in for x most of the time? 1, 0, 2. Okay, so I would usually recommend small numbers. If there's a fraction involved, I would choose a multiple of the denominator, like I did on the warm-up. It was 1/2. I knew I could easily take a half of things like -4 and 2. So there are tricks to making this a little bit easier on yourself. Questions before we get into the graphing? Anybody need more time on this slide? Okay. I put graph paper out in case we needed it. We should have only needed 1 page of it. If you prefer to draw your own graphs, that's fine. All right, what was step 1 from that last slide? So we need an input-output table. I don't care if you want your input-output table to go side to side, which is what we've done a lot. Sorry, not y. We would have f of x instead of y. Or you can make your input-output table go up and down. It doesn't matter to me. I usually like an up and down one. If you prefer it side to side, that's fine. So I'm going to use the up and down. If you prefer side to side, keep it that way. We have to decide what we're putting in for x. I'm going to tell you we need at least 3 numbers in for x.
0, 1, 2.
Okay. We could use 0, 1, 2. We could use 1, 2, 3. We pick the x's if they don't give them to us. Might as well make it easy on ourselves. Dominic?
So on your book it would say like answers will vary.
Yep, it could say your answers for your chart could vary, but everybody's line in the end should look the same.
Question.
Yep.
So like, you know how we're doing like the X and the lines?
Yep.
How do you, what, how is this different from them or something?
This isn't really different from them because our output column is f of x, or you could call it y. It's the same thing.
Oh, so we just say Y.
All right. What did we get when we plug in 0 for x? Not 0. 2 times 0 is? 0 minus 5 is? Okay, so f of 0 is -5. That goes on our output side. What about when we plug in a 1? Two times 1? 2 minus 5? Okay, that goes on our output table. Then we're plugging in 2. 2 times 2? 4 minus 5. All right, so then we have to graph those points. Might actually be a little tricky to fit 0 in on this graph that's shown here. So you might also have to adjust your axes on yours if you want to put your axes in the middle of that graph instead of in the corner where it starts off. How am I going to get to the point 0, comma, -5? Not up 5. Down 5. So 0, we don't move left or right. We go down 5. My graph only goes to 4, so that's why I said you might have to move your axes to the middle of it and ignore the bold axes they give you. So draw in your own axes instead of using the one that's in that corner. All right, what about the point 1, negative 3? Write 1 down 3, and the point 2, negative 1. Write 2 down 1. And our points should lie in a straight line. We have to put a line through them. That was step 3. Make sure that it is a straight line, so use like your ID or something to show me that that's a straight line that goes all the way through the graph with arrows on the ends. We will have to get through more of those possibly tomorrow. Your homework is on page 125, 1, 2, 3 through 27 odds, and number 30.